Hello everyone and welcome to Paragon Pathfinders. In today's interesting math class, I'm going to show you two things. Number one, how to derive the quadratic formula, and secondly, what the discriminant tells us about the roots of every quadratic equation. Without further ado, let's get right into it. Let's begin with the derivation of the quadratic formula. Here I'm going to write my solution. And then how do we derive this very formula, or where does it come from? Well, we need to know that the general form of every quadratic equation is given by ax squared plus bx plus c equals 0. This is the general form of every quadratic equation. And we can derive the quadratic formula from here by completing the square. You can only do this by completing the square. So that's why it's really very important for you to know how to complete the square before you try this. But I'm going to show you how to do it at the same time so that you will have no issues deriving this very formula. Now, the first thing that you have to do is to make sure that the leading coefficient is equal to 1. The leading coefficient is a, right? Now, suppose right now you have a quadratic equation in the form of 2x squared minus 3x plus 4 equals 0. The leading coefficient is 2 because that's our a. Our a is the number that comes in front of the x squared. Our b is the number attached to the x. So our a equals 2. Our b is the coefficient of x, which is -3, and our c is the constant term, which is the term that does not have an x attached to it, and in this case, the value is 4, right? So that's how to find your a, b, and c. And now you must make sure that the leading coefficient is not greater than 1, and it must not be 0, okay? So whenever you are completing the square, you must have this in your mind. And this now implies that we are going to divide the entire equation by a, okay? First and foremost, let me move the c to the other side. So we are now going to have ax squared plus bx is equal to -c. The next thing to do is to divide the left-hand side and the right-hand side by a. So this a here cancels out with this, and we are left with x squared plus bx over a. This is equal to -c over a. Now, having divided both sides by a, the next thing that we're going to do is to get half of the coefficient of x, square it, and add to both sides of the equation. Let me repeat the steps again. Step 1, transpose the constant term to the right-hand side, which we have done already. We transposed our c to the right-hand side. The next thing to do is to divide both sides of the equation by the coefficient of x squared, which is our a, to ensure that the leading coefficient is 1. After dividing both sides by a, the next thing that you have to do is to get half of the coefficient of x. The coefficient of x is the number attached to the x, which is b over a, right? So we have b over a. How do we get half of b over a? We simply multiply b over a by 1 over 2 or by half. So multiplying b over a by half gives you half of that value. For example, suppose right now you want to get half of 4. You can simply multiply 4 by 1 over 2. So 4 times 1 gives you a 4, and this is 4 over 2. And 4 divided by 2 gives you a 2. So multiplying a number by half gives you half of that number. In this case right now, we are going to multiply b over a, which is the coefficient of x, by 1 over 2, then square it and add to both sides. Now let's do this. B times 1 gives you b, and then a times 2 gives you 2a. So this implies that half of b over a is b over 2a. Now we are going to square it and add to both sides of the equation. So right here we have x squared plus b x over a, then plus, remember to add to both sides, and then you square. Then you have b over 2a, you square it. So let's do for the right hand side as well. And on the right hand side we have b over 2a all squared again, then minus c over a. We have squared the half of the coefficient of x and added it to both sides of the equation. Next up, we can go ahead and simplify the expression, but I'll leave the left-hand side as it is. I'm going to tell you why when we introduce the square root property on both sides. Right here we have x squared plus bx over a. Then we have plus b over 2a all squared. You can choose to expand this by distributing the square across everything inside the bracket, or you can choose not to. But I choose not to because it helps me simplify the expression easily when I want to introduce the square root property on both sides. Now this is equal to, let's distribute the square on everything inside the bracket for the one on the right hand side. So the square goes to the b and also goes to whatever you have below. Now b raised to the power 2 gives us b squared over 2 raised to the power 2 is a 4, and then a raised to the power 2 is a squared. Then we have minus c over a. Next up, let's simplify our right hand side. On the left hand side, we still maintain everything. We have x squared plus bx over a. Okay, then plus, right here we have b over 2a. Remember that I said if you expand, if you distribute this square across everything in here, it's okay. But if you still choose not to, it's still okay. Okay, you've not made any mistake yet. So now, we now have two fractions. This is fraction 1 and this is fraction 2. So how do we subtract them? Since they are subtracting here, you can see there is a subtraction sign. We're simply going to get a common denominator for the two fractions. So the common denominator for 4a squared and a is 4a squared. That's the common denominator between the two. Let's now divide and multiply. 4a squared divided by 4a squared gives us a 1. 1 times b squared is b squared minus, again, 4a squared divided by a would give us 4a. And then 4a times c gives us 4ac. Remember that when you get to this point, you must make sure you combine the two fractions into a single fraction by getting a common denominator for the two terms. And then you can now go ahead and simplify. Now, having gotten to this point, let's now work on the left-hand side. Right here, once you get to this point, here are things that you must do. Pick the x term, you write it down. So we have x. Ignore whatever you have at the center, right? Now, go to the last term, pick the sign, and then you have plus b over 2a, and then you square. Okay, that was why I said don't expand yet, so that you understand how to do this. Like I said, drop the x term, please ignore the square. Okay, doing this gives us a perfect square trinomial that when you expand this right now, if you expand this, if you expand x plus b over 2a squared, you will get the original expression back. You can try that on your own, Once you expand x plus b over 2a squared, you get everything here back. That is how it works, right? So you can try that on your own. Like I said, pick the x term, ignore the middle term, pick the sign, just drop the sign. You can see the x is here, the plus is here. Then whatever you have inside the bracket, you drop it and then you square everything. Like I said, expanding x plus b over 2a squared gives you the original expression. It's going to give you x squared plus bx over a plus b squared over 4a squared. That's what it's going to give you, which is the original expression. Now this is equal to b squared minus 4ac over 4a squared. What do we do next? We can see clearly that we have a square on the left. So to remove this square, we're going to introduce a square root property by squaring both sides. So let's go ahead and square both sides. Right here we have x plus b over 2a all squared. I'm going to square them. This is equal to, we have b squared minus 4ac over 4a squared. Introducing the square root property, so we square both sides. What you do to the left, you also do to the right. Don't forget. So this square and this one, they cancel out. And once they cancel out, we are now going to be left with x plus b over 2a equals, so when you take the square root of a number, you're going to get two values. One is for the plus and the other is for the minus. So we now have plus or minus b squared b squared minus 4ac all over 4a squared. Correct. Now let's go ahead and separate this. Since we have two terms, we can write it this way: x plus b over 2a equals plus or minus. Right here we have two terms. The first one is b squared minus 4ac over, the next one is the square root of 4a squared. So this is correct. If you have, for example, you have the square root of a over b, this can be written as the square root of a over the square root of b. I'm using the same square root property to simplify this expression so that we don't get confused along the line. Now let's simplify this. We have x plus b over 2a equals plus or minus. For the one on top, we cannot take the square root of b squared minus 4ac because this is not a single term. There are two terms here, so we have to leave it as it is. So we have the square root of b squared minus 4ac. Since they are subtracting, we cannot take the square root. Even if they're adding, we cannot also take the square root. We have to leave it as it is. Now this is over the square root of 4 is 2, and the square root of a squared is a. Okay, correct. So the square root of 4 is 2, and the square root of a squared, for example, if you have a and then this is all squared, right? So this square cancels out with this, so that gives you an a. So that is just how it works. Or let's say, for example, you have a squared. So this square cancels out with this, you still have an a left. Now, having done this, what next do we do? We can go ahead and solve for x. So we have to isolate x by transposing the b over 2a to the right hand side. And when we do that, we have x is equal to, so this positive b over 2a now becomes a minus. We now have minus b over 2a, then plus or minus the square root of b squared minus 4ac all over 2a. Okay, correct. Now, we have two fractions here, fraction 1 and fraction 2. They have a common denominator. And since they have a common denominator, what do we do in this case? We can simply pick one of the denominators and add or subtract the fraction. So we are now going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula that we are talking about. This is how to derive it. Now we're done with the first part of the question. Let's now go ahead and look at the discriminant. So the discriminant is simply what you have in here, which is b squared minus 4ac. The discriminant, let's say in this formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the discriminant, it's called d, okay, is equal to b squared minus 4ac. So this discriminant tells you the nature of roots of every quadratic equation. When we say roots, for example, what are we talking about? We actually mean the answers or the solutions. When you solve a quadratic equation, you are going to arrive at two solutions or at two answers, right? So the discriminant, it's also sometimes written like this. Okay, yeah, something like this. So whenever you see something like this, don't get confused. They're actually talking about the discriminant. This is how it is written. X equals negative b plus or minus. And inside the square root, they will not put a b squared minus 4ac. You only see a little triangle here. And this is over 2a. So this also talks about a discriminant. So in case you are writing an exam and you see this shape instead of this, please know that they are also referring to the discriminant. Now, what does the discriminant tell us? So there are three conditions that we need to know. The first one is, here we have if b squared minus 4ac equals 0. So if, for example, you test for the root of any quadratic equation at all and you get a 0, it means that the roots are real and repeated. So let me explain to you what I mean. So suppose right now you have a quadratic equation. Let's use one as an example so that we can understand better what I'm talking about. I'm trying to get a quadratic equation that we can use right here for learning purposes. Okay, just a minute. I'm trying to get an equation that we can use. Okay, so right here we have x squared minus 2x plus 1 equals 0. Now from this, let's deduce our a. Our a is a term attached to the x squared. So since there is no number here, it's simply a 1. A equals 1. B equals the term attached to the x, or the number attached to the x, which is negative 2. And then c is a constant term that does not have an x attached to it, and that is 1. So for this very quadratic equation, we do not know the nature of the roots. We don't know if the roots are real and repeated. We don't know if the roots are real or distinct. We don't know if the roots are imaginary or complex. So let's use the discriminant to test for the nature of the roots. Let's substitute. So we say b squared minus 4ac equals 0. Our b here is negative 2, so we substitute. We have negative 2 squared, then minus 4. Our a is 1, our c is 1. So let's see if we're going to get a 0. Okay, so negative 2 squared gives us a positive 4. Then minus 4 times 1 is a minus 4, and minus 4 again times 1 is a minus 4. So 4 minus 4, that gives us a 0. We have 0 equals 0. So if, for example, your discriminant gives you a 0, it simply means that that quadratic equation has repeated roots. The roots are repeated, okay? So real and repeated roots. The roots are repeated. So when we say the roots, we mean the answers. So in this case right now, if you solve this quadratic equation, for example, you're likely to get x equals 1 or x equals 1. So the answers are going to be double. They're going to be the same and they're going to be repeated. You could be getting x equals 2, x equals 2, x equals 3, x equals 3. So if the discriminant equals 0, it means that the roots are real or repeated. They are real and repeated, right? So that's the first condition. Now, what if we have something like, let's say, for the second condition, we have b squared minus 4ac is greater than 0. So if, for example, you solve or test for the nature of the roots or the nature of the answers, and then you find out that your discriminant is greater than 0, that is, you get a 1, a 2, or 3, it means that the roots are real and distinct. So let's use a quadratic equation to test and see what we're talking about. So right here we have x squared minus 3x plus 2 equals 0, right? So from this we can see that our a is 1, our b is negative 3, and our c equals 2. So using the discriminant, let's just check and see what's going to happen here. So right here we have our b is negative 3, so this now becomes negative 3 all squared minus 4. And then our a is 1, our c again is 2. So negative 3 squared gives us a positive 9. So minus 4 times 1 is a minus 4, and minus 4 times 2 is minus 8. So this is equal to 1. Have you seen? So since the discriminant equals 1, you can see that 1 is greater than 0. It means that the roots are real and distinct. So we say roots are real and distinct. Okay? So when we say distinct, it means that they are different, they are not the same. Okay? Unlike the other one where the roots are real and repeated, where you have x equals 1, x equals 1, x equals 2, x equals 2. Because whenever you solve any quadratic equation, you are going to get two solutions. Okay? Because the highest power of x is 2. So it means that the real, in this case right now, if your discriminant is greater than 0, it means that the roots are real, but they are distinct, where you can get something like x equals 1 and then x equals 4, okay? Or you can get x equals negative 1, x equals 3. So it means that the roots are real, but they are distinct, right? Like they are kind of not the same. So that is actually what it means. So for the other one, for the last one, where we have for C, we have the discriminant b squared minus 4ac to be less than 0. So for this right now, I'm going to leave this up to you so that you can do more research on it. and you can let me know what you think about it in the comment section. So for this one right now, whenever you solve or test for the roots and you say that you get a -1, okay, this is for the testing using the discriminant, and you get a -1, it means that the roots of that quadratic equation are purely imaginary or complex. So we say imaginary or complex roots, okay? So you do more research and tell me what you think about this. Like I said, if the discriminant is less than 0, that implies that the roots are imaginary or complex. Thank you so much for being there and for following me thus far. In my next video, I'm going to be showing you how to graph quadratic functions. See you in the next video, and bye.